welcome to this video. So in this video I will be showing you how to train an object detection model using TensorFlow 2. So just head over to my website, go down below and under training SSD models, open this link over here. I've already made a video on this topic for TensorFlow 1, so you can go ahead and check it out as well. Now for TensorFlow 2, let's start with the training process. Okay, so you can read this article that I've written. I've explained all these steps in much more detail over here, so this will help you. But just for demonstration purposes, I will be using my Colab notebook. I've also made this Colab notebook mentioning all the steps over here as well, so just to make it easier for you. Okay, so this is the notebook that we will be using. So okay, for the first step, let's begin. Click on File, save a copy in Drive. This opens up a copy on your browser. So now we can use this. Click on Connect. Once this is connected, click on Runtime, change runtime type, make sure this is GPU. Okay, now we can begin. Run the first step, that is import libraries, and we'll see the TensorFlow version. The default TensorFlow version for Google Colab right now is 2.4.1, so that's okay since we are doing this training process using TensorFlow 2. Now for the next step, create these folders in your Google Drive. Open your drive. Okay, create a folder named custom tf2. Okay, and create another folder named training inside the custom tf2 folder. This folder is where we will be saving the checkpoints during the training process. Okay, go inside custom tf2, create this folder, and then lastly create another folder named data inside the custom tf2 folder. Again, create another folder named data. That's it. For the next step, create and upload your image files and XML files. We need our images and their corresponding label files, the annotations. Now if you go over to this blog over here, I've given a brief overview of how to label your dataset, how to collect images and label them. Okay, so now for this we need to do a couple of things. First, create a folder named images, and we have to put all the images of our dataset inside that folder. And then next, create another folder named annotations and put all its corresponding XML files, the label files, in that folder. So okay, let's go ahead and do that. Okay, so I already have these two folders over here on my desktop. So I've put all my dataset images in this folder named as images, and I've put all its corresponding label files, the Pascal VOC format label files, these XML files, over here in this annotations folder. Just create their zip files and upload both these zip files to your Google Drive right over here. As you can see, just make sure that all these image files have JPG format, as the generate underscore tf record file, the script that we will be using in the next step over here, this has only JPG written in the code. So if you are using other formats, you can make changes in this file accordingly, but if you don't want to do that, I'd suggest using only JPG format files. Okay, so that's done. Now for the next step, okay, before we move on to the next step, I've also made an article on how to label your dataset. I already had these labeled XML files, so how to get these files, you can head over to this article and read more about collecting datasets and the labeling process. This will help you. Okay, I also made a few videos on this topic, so you can go ahead and check them out. Okay, let's move on to the next step. Upload the generate underscore tf record.py script file to the custom tf2 folder. You can download this file from here. I also uploaded my label underscore map.pbtxt file. I'll explain what that does later. So for now, just download this generate underscore tf record.py script file. Okay, so now I have this file over here on my desktop. You can close this. You have to upload this file to your custom tft folder over here. Okay, it's done. Now for the next step, step 5, mount, drive and link your folder. Now as you've seen in my previous videos, this process will be the same. Allow, copy this, press enter. Now okay, what this step does is this creates a symbolic link so that this path is equal to / my drive. You don't have to type this every time. Okay, so this just makes it easier. Now let's move on to the next step. Clone the TensorFlow models Git repository and install TensorFlow object detection API. Just run this. Let me show you one thing. If you head over to my article, I've mentioned all the documentation and references over here. So this is the official TensorFlow object detection API installation, which you can read over here. TF2 installation guide and object detection documentation. As you can see, this is the object detection API installation procedure for TensorFlow 2. As per the latest requirements, we don't have to type use feature 2020 resolver, as that is the default now. So we can just type this and this will install all these files required for object detection over here. As you can see in the content folder in your Google Colab. I won't be doing this in your drive as this occupies a lot of space, so I'm trying to avoid that. Okay, as you can see, it has installed all these packages and it has installed TensorBoard 2.5.0 and has also installed TF-Slim, which we need, TF Models Official, TensorFlow Estimator 2.5.0 and TensorFlow 2.5.0. So it has installed the default Colab TensorFlow, that is 2.4.1. Okay, so now let's move on to the next step. Test the model builder. Test if the installation process was successful or not. This will give you an output like this. Okay, so there was no error. Okay, as you can see, so our installation process was successful. Now we can move on to the next step, step number 8. Navigate to my drive custom tf2 data folder and unzip the images.zip and annotation.zip files into the data folder. Just run this. Now what this does is this unzips both these folders inside this data folder and creates two folders named images and annotations. We'll see that next. Okay, so that's done. Let's move on to the next step. Create test labels and train labels. We have to create these two folders. Okay, for that what we will doing is we will be dividing annotations into two folders where test labels will have 20% of the label files and train underscore labels will be having 80% of the label files from this folder. So first make directory, create folders, name test labels and train labels. Then it will move 20% of the labels into test labels. So since I have 1370 images, 20% of that is 274. So I have written 274 over here. You can change this accordingly to 20% of your number of labels. Okay, run this, and the last line what it will do is it will move the rest of the remaining labels, that is 1096 labels, to the train underscore labels folder. So that is 80% of the XML files in annotations folder. Okay, so now that's done. This is how the working directory will look at this point. Data, inside data, which is the current working directory, we'll have an images folder, annotations, and right now since we've moved all these files from annotations folder to these two, annotations folder will be empty, and now these two folders will contain all the labels, 80% in this and 20% in this. You can just go ahead and confirm. Okay, so as you can see, just created these two folders successfully. Now we can move on to the next step. Create the CSV files and the label underscore map.pbtxt file. Again, the current working directory is this, my drive custom tf2 data. Now run the XML to CSV script below to create the test underscore labels.csv and train underscore labels.csv file. This also creates the label underscore map.pbtxt file using the classes mentioned in the XML files. So let's run this first. Okay, it has successfully converted train labels XML to CSV, successfully created label map underscore .pbtxt. Okay, it has done all this. Now this is what the working directory will look at this point. We have 3 additional files over here. Let's go ahead and check it out. Okay, so as you can see, we have these 3 files over here. You can also check these files over here in the file section. So this will show up here as well. Okay, now let's move on to the next step, step number 11. Create train.record and test.record files. Run the generate underscore tf record.py script file and the file that we uploaded in the custom tft folder, this one. So just run these two commands for train.record. This is the command. This will use the generate underscore tf record.py script file from the custom tft folder, and then the train underscore labels.csv file and the label map.pbtxt file that we created in the previous step. Then next is the images folder, and then finally the output file name, that is the train.record, and again do the same for test.record. Just run this block, and as you can see, this has created successfully created the tf records train.record for 80% of the files, that 1096, and again for test.record it should be 274. There should be no error. Now again, as you can see, we have both these record files over here. Okay, so this is around 83 megabytes and this is around 28 megabytes. So okay, let's move on to the next step. Download pre-trained model checkpoint. So for this TensorFlow 2, we will be using SSD mobilenet v2 FPN Lite 320 into 320 Coco 17. You can also find a list of detection models for TensorFlow 2 over here. Again, if you head over to my article, you can read all these references. This will help you a lot to understand this entire process and everything associated with TensorFlow and object detection training process. So okay, so as you can see, these are the detection models that we can use. We can use any of these, so I will be using this one, SSD mobilenet v2 FPN Lite 320 into 320. So okay, let's run this block. This will download this zip file for it and unzip it over here. Okay, as you can see, we now have this. This will have the checkpoint and the saved model in it. Okay, now we can move on to the next step. Get the model pipeline config file, make changes to it and put it inside the data folder. Okay, so we can download the config file for this model that we used. This was a pre-trained model. Now we need the config file for this. You can find the config file for this over here. Content models, research, object detection, configs and TF2. Let's close this. Go over to models, research, object detection, configs. This is where we'll have the config files for TensorFlow 2. Okay, we will be using this file, SSD mobilenet v2 FPN Lite underscore 320 into 320 Coco 17 underscore TPU 8. You can download this, make changes and upload it to the My Drive custom TF2 data folder, or you can simply just edit it over here and then copy this using this command. That is much easier. Now let's make these changes. Change number of classes to your number of classes. Change this to 2. That's my number of classes. Change test.record, train.record and label map path to the paths where you have created these files. These paths should be relative to your current working directory. Go inside this file section and go to where you've created these files, custom tf2, inside data folder. We have all these files over here. Now this for eval input reader, this is for test.record. So just go to test.record, right click, copy path and paste it over here. That is it. Now for this label map path, copy path for this, paste it. Now again do the same for train underscore input reader. The label map path will be the same. For train.record, copy path, paste. Okay, now that's done. Change fine-tune checkpoint to the part of the directory where we downloaded the checkpoint from step 12. We downloaded the pre-trained model checkpoint in the previous step, this one, the zip file, and then we unzip this over here. We have to give the path to this checkpoint 0. Okay, so that's what we'll be doing over here. As you can see, fine-tune checkpoint path over here. Open this checkpoint folder, copy path till this checkpoint, paste it, / and change this to checkpoint 0, as this is the file that we need. We need to point it to this. Next, change fine-tune checkpoint type with value classification or detection depending on whatever you're training it for. I'm training this model for object detection, so I'll use detection over here. Change batch size to any multiple of 8, and this depends on your GPU capability. So since I am on free version of Colab, I won't be using a very high batch size. I'll simply set this to 64, and then lastly change number of steps to whatever you want your detector to train it to. Default is 50,000. You can change it to 100,000 or 200,000, whatever you like. We can also change this later in the training command by introducing a parameter named as num_steps. You can change this there as well. Okay, so we've made changes. Control S, save the changes. Now just run this command. This will copy that config file that we just edited from this location to the data folder. As you can see, we have this config file over here. Now double click and check if all the changes we've made are here. Yes, as you can see, everything looks fine. Okay, so I've double checked. Now we can move on to the training process. First, load the tensor board using this command. Now this is log directory. We'll be using the folder where we will be creating our checkpoints during the training process. We'll log that using tensor board. It won't show anything right now since we haven't started training process, but once the training process starts, you can refresh this and you will see updates over here. Okay, now moving on to the next step, step 15, train the model. We have to navigate to the object detection folder in Colab VM. So basically now we were working in this directory over here, custom tf2 data. That was the current working directory. Now next, just change your current working directory, change directory to this content models research object detection. We will be going inside this folder because this is where we have all the scripts for training and evaluation, etc. We will be using model underscore main underscore tf2 for training. Now this is the command for it. Now I've already set the command in a way that you won't have to make any changes over here. Just let me once quickly run through the usage for it. So this is the script file. Pipeline config path is where we have our config file that we've edited with the changes in step 13. And this is the model directory where the checkpoints will be saved during the training process. The folder that we created. So this is where we'll save our checkpoints during the training process. This is the model directory over here, and that's it. You can run this. Now this is for training. Now if you want to evaluate at the same time you're training, you can use this 15b next command. The command is the same except that we have one extra parameter over here, that is checkpoint directory, and that's the same folder that we save our checkpoints to. So what it does, it evaluates the progress at the same time it trains the model. That is optional. If you want, you can do that, but this will work just fine. This is just to show you how you can get started with the training process. This will take a few hours as we're training this on Google Colab. So we can pause this and come back later. Okay, so in case you get disconnected, to restart your training process, all you have to do when you get connected again, you have to run all the steps from the start again, but skip steps 2, 3, 4 and steps 8 to 13. So run this import libraries. You can skip steps 2, 3 and 4. We've already done all these, we don't need to do this again. And then run step 5, mount drive, clone the TensorFlow models Git repository, install TensorFlow object detection API, test the model builder, and that's it. Now after that you can skip steps 8 to 13. We've already done all these steps. Okay, until 13 we don't need to do these. We already have all these files over here in the data folder. So okay, now run step number 14. As you can see, I already had one checkpoint 1 saved over here, so we can restore our training process from here. Okay, let's go over to this section. The training automatically restarts from the last train checkpoint itself. So whatever the last train checkpoint over here, it can be checkpoint 1, checkpoint 2, checkpoint 5, 10, whatever, it will automatically start training from that. You don't have to make this change. So let's run that and see. Sorry, we have to first navigate to this object detection folder. Make sure to always run this. Okay, now let's run this. At step 100 the loss is 0.558. so just one more thing. So over here, as you can read, for best results you should stop training when the loss is less than 0.1 if possible, else just train the model until the loss does not show any significant change for a while. So let all the 50,000 steps run its course, so we'll see what the loss is at that point. Now as you can see over here, one thing to note, this takes a while to train. The output will look frozen. This only displays output every 100 steps. So don't think that the training process has stopped or crashed. Just be patient. This depends on your GPU capability and the batch size. So we can wait, and this will give you output every 100 steps, and then it will also save a checkpoint every few steps over here. I'll pause this here right now and come back later once all the steps are done. Once we finally trained, my loss had reached around less than 1 at checkpoint 36, so less than 0.1. So I'll be using this checkpoint 36 to test my object detection model. So now we can move on to the next step after the training process. The next step is step 16, that is test your train model. So first, for that we'll be exporting an inference graph. So to export an inference graph, now these are the scripts that we will be using. Again, go to the object detection folder. Now you can see we have these scripts over here: export TF-Lite graph, export TF-Lite SSD graph, export inference graph. Okay, so but for TensorFlow 2 we have exporter underscore main underscore v2 over here, as you can see. Okay, so let's run this command. First let's quickly go over this command usage. So python exporter main v2 train checkpoint. Again, this is the folder where we have all our checkpoints saved, this folder. Next is the pipeline config path, where we have a config file that we edited and used for the training process. And finally the output directory, where we'll create our inference graph. Just write this will create a folder named inference graph inside the data folder over here. This will create an inference graph folder over here and save the inference graph inside it. Let's run it. Okay, as you can see, assets written to my drive custom TF2 data inference graph saved model assets, and okay, has been used to save the saved model, writing pipeline config file. Okay, so if you head over to the drive, you'll see a folder created by the name inference graph, and we'll have the saved model assets written over here. So this is the file that we need, saved model.pb. We have this, we have our graph inside it, so that's all we need. The saved underscore model.pb file over here, it's around 10.5 megabytes, so that seems okay. Now to test your trained object detection model on images, we'll be running this block. Again, the current working directory is the object detection folder, the one that we're already inside right now. Okay, so run this first cell block. This is optional. This is just to download a font, the font that we'll be using on our detection boxes. This will just make it a little bigger. This is optional, just download it and unzip it, and then we'll be using this code over here. Now again, I've already written all the paths over here, so you don't have to make any changes if you followed all the steps in this tutorial. So the path to the saved model, as I mentioned earlier, will be inside inference graph saved model. This is the graph that we need. So we have the path to the saved model. The next path to the label map is inside data folder. We have the data folder right here. We have the label map file over here, and that's it. And then this is the image path, the image that we will be using to test our object detection model. So I have an image in my drive, mask test images, image1.jpg. So I'll be writing the path to this image over here. Okay, that's it, and you don't have to make any other changes, just run this. Okay, so as you can see the result, it has detected the mask in this image. I have these images saved over here as I mentioned earlier. Next I have a few other images over here. Let's test this one without mask. I'll change the path. Okay, so as you can see, this has also successfully detected this. It has predicted this image without mask. So our trained object detection model is working fine. Okay, so that is how we train a machine learning model for custom object detection using TensorFlow 2. This was on Google Colab. So we used an SSD model in this training process. Check out this article and you'll find everything is in much more detail over here, and also all these references here down at the bottom will help you a lot. Go ahead and check these out. And okay, so that's it for this video. If you enjoyed this video, please click on the like button and make sure to subscribe to this channel. And okay, I'll see you in the next one.